Hi guys, welcome to Statistics Online. Today we're going to be talking about simple random samples. So today you should be able to walk away from this video knowing how to do a simple random sample by using like slips of paper or even technology with your calculator. And then I want you to truly understand sampling variability and the effect of increasing the sample size will have on the variability. Okay, so let's go ahead and just jump right into it. Let's talk about simple random samples. So in lesson 3.2, we learned that choosing a random sample is a good way to avoid bias in our study. So in this lesson today, we are going to talk about the details of how to select a random sample more specifically. All right, so a simple random sample of size n, just depends on how large our sample is, and that would be n, is a sample that's chosen in such a way that the group of individuals, all of the n of our individuals in the population has an equal chance, right, of being selected as the sample. All right, so I would like you to get out your calculator, and did you know that your calculator can generate random numbers? Super cool. So I went ahead and put down the notes for you in the notes, but I do want to walk through with you on your calculator. So grab your grab your graphing calculator, and let's go ahead and start off with choosing the math button. So the math button is 2 below your second value, and then we're going to tab over to the probability. And once you have that, for me it's option 5, the R, A, and D, I, and T. For me it's option 5, so I'm just going to hit 5, but you want to tab over. So on my calculator, mine gives me a lower and an upper, and it gives me also an n value. So the n value is how large my sample size is going to be. And so let's go ahead and just choose numbers from like 1 to 35, right? So I want this calculator to randomly give me a number between 1 and 35. So to do that, I'm going to put 1 as my lower, 35 as my upper, and I want 2 numbers. I want 2 random numbers between 1 and 35. So the n value I'm going to press is 2, and then I'm going to hit enter, and it gave me 33 and 34. Super cool. Now if you hit the enter again, without even going through that process, if you just keep hitting enter, it just keeps randomly giving you 2. So I just got 25 and 35. 23 and 11. You can change that n value, and you can make your lower and upper values as large as you want. Now, when you are choosing a simple random sample, we make selections without replacement. Okay, so that means like once an individual is chosen for that sample, we don't choose that individual again. Now, most technology does not do that. So if it gives you the like the same number twice, just ignore the second one and do it again. All right, cool. So let's just talk about a problem if we did not have our calculator or any type of a software that would help us generate. How could we do it basically old school? So a safety engineer at an automobile assembly plant knows that 180 of the pickup trucks will be assembled tomorrow. So to meet the federal regulations, the engineer must select 5 of those vehicles for a safety testing. So describe how you would select a simple random sample of 5 trucks using sheets of paper, slips of paper. Well, guys, I just would recommend you have 180 vehicles, so this is how you would like describe it. You would say every vehicle, you would give it a number, 1 to 80. And then the papers need to be of the exact same size, right? Equal shapes of size, if they're all in rectangles, or exactly the same length and width. And then you would write down that vehicle, card 1, 180, and then you would make sure that they're shuffled really good, like inside of a hat or something like that. And you would randomly pick one out. So that would be one way, old school method, that you could do that. All right, so, I want to back up. Can I back up? I just want to back up for a minute. So think about the sample size of 5. If you have 180 trucks, if you're pulling 5, do you think that's enough, right? 5 is enough to meet federal guidelines if you're only checking 5 out of 180. And what would that number be? What essentially we would like to, I don't know, check every single truck, right? We would like a census. We would like to check all of them for safety testing, but I don't know, 5 just seems really low to me. And so let me show you something that we can reduce the sampling variability is by using a larger sample size. So take for instance, the other day, we were counting the word, like how long the word is, right? The letters in the word, in the Gettysburg Address. So the first example here, right, this dot plot here was the mean, the average word length when we were taking a sample of 5. Remember, you had to randomly take a sample of 5 and find the mean. And so this is every single time. Each dot is every single mean when you had 5 words. And then this, yeah, this was the mean, and it spreads pretty far, right? Look at the variability here. You're going from 2 all the way to 8. Now, what if instead of 5 words, and we found the mean word length, what if we increased it to 20? Then look what happens. Instead of 5 words and then finding the mean, we did 20 words and then find the mean. So this is each time that we found the mean of 20 words, the mean length. So the difference here is that if you have a larger sample size, instead of 5, we went with 20, it is definitely going to reduce the variability. Now, essentially, if we had every single word, right, which we do, but if we were to find the mean word length of every single word in the Gettysburg Address, that would give us just 1.1 number. But this right here tells you that it's getting closer to the true average if we had a census. All right, so now we're starting to talk about inference. It is the process of drawing a conclusion, right, about the population on the basis of sample data. And that is called inference because we infer information about the population, what we know about the sample. So if I were going to go back to this example, I would say, well, I know that it's going to be in between about 4 and 6, I infer, by looking at the sample size of 20. All right, so here is the last slide for today, and it's just a problem that's posing is the median household income in a random sample of 371 Virginia households is $61,784. Okay. Do you think that the median income of all Virginia households is equal to 61,784? We know that it's not. Okay, so what's really important is to write down that the different random samples will produce different medians. Now we've seen that, right? They only sampled 371 and it gave the 61,784. What if they did 500? It would give us a different median. All right, so if the sample size was increased to 1,000 households, what effect would that have on estimating the median income? Well, that definitely is going to get us more close to the true actual median, right? I mean, the larger the sample size, the reduced variability it is going to have. So we definitely would expect our estimate to be closer to the true median of the true median income in Virginia households. Now, ideally, we would like to ask every single household and get a census, but in this case, it probably wouldn't be feasible, and so therefore we are looking for the best sample possible. All right, well, I hope you guys really enjoyed today's lesson, and I will see you guys next time. Bye.